Hello, we are studying about GATE 2011. Look at the given differential equation. We are going to find the corresponding waveform output y of t when the input x of t is a unit step input and the initial conditions are relaxed, that is zero initial conditions. Okay, there are four options are given. So this is a differential equation given. We can specify the output response in two ways. If we know the time domain expression for the system y of t, okay, for the system output y of t, if you know the time domain expression, you can tell the waveform, and otherwise from the frequency response, that is by obtaining transfer function y of s divided by x of s, which is transfer function, and from that one we can say the poles of the closed loop system, and from these poles also we can specify about the response. Okay, and if you observe, this is a second order system as it is d square y by dt square. So this is a simple second order system. For a simple second order system, okay, we know that one, it is a s plane and it is sigma, this is j omega, left half of s plane, and this is left half and it is right half. For a second order system, there will be two roots for the characteristic equation. Roots of characteristic equation is nothing but poles of the transfer function. And now, if both the poles are on the imaginary axis, which are going to be mirror image of each other. So let us assume this is the first case when the poles are going to be opposite in magnitude, but both are on the real imaginary axis itself. Then the response is, this type of system is called as undamped system. Undamped system, and the output waveform is going to be looking like a sinusoidal waveform, that is the waveforms doesn't get reduced. Okay, undamped oscillations, undamped waveform you will get. And if the poles are going to be on the left hand side and both are going to be complex poles, that is it will consisting of real part as well as imaginary part. Real part is this point and imaginary part is this one. Okay, so then the system is called as, this is second case, the system is called as underdamped system. Then the response is going to be of this nature. And if both the poles are going to be at the same place, that is double pole on the negative real axis, then it is critically damped system. This is the third case when both the poles are at the same location. So the response is going to be looks like this way. Otherwise, if both the poles are on the negative real axis but both are going to be not at same place, that is what the fourth case. Okay, then it is called as, fourth case is overdamped system. For this overdamped system, it will be looks like a critically damped, but it is going to be still more sluggish. The system is going to be still sluggish system. It takes more settling time to reach the final value. That is what fourth. And there is one more case. At least if one of the pole is going to be present on right half of S plane, then the system is unstable and the graph is going to be looking exponentially increasing. So this is fifth case. If at least one of the pole is going to be on the right half of S plane, then the system is unstable because the output increases exponentially as time increases. So now we are going to find which case is going to be related to the given expression. Okay, for that one we need to apply the Laplace transform. Okay, then we are going to find the poles. From that pole location we can specify the output. Okay, now apply Laplace transform and it is given that one initial conditions are 0. Okay, so this is 100 s square minus 20 s plus 1 is equal to plus 1 into y of s is equal to x of s. Okay, And now y of s by x of s is equal to transfer function, which is nothing but 1 by 100 s square minus 20 s plus 1. So you can write it as y of s by x of s is equal to, okay, this can be finally written as 1 divided by 10s minus 1 whole square. If you get factorized, you will get this one, 10s minus 1 whole square, which implies, okay, if you take this 10 common, then it will be 0.01. 10 square is nothing but 100. 1 by 100 is 0.01. 0.01 divided by s minus 0.01 whole square. So there will be two poles are on the right half of s plane. Look at this one. There will be two poles on the right half of s plane at 0.01 location. Okay, double pole at 0.01. So two poles are at the same location, but they are on the right half of s plane. So the system is going to be unstable system and the output increases exponentially. So the right answer for this question is A. A is the right answer. Okay, this we can also obtain from the time domain expression. Okay, if you are going to write this one in the time domain, so take inverse Laplace transform. If you take inverse Laplace transform for this 0.01 by s minus 0.01 whole square, okay, so Laplace inverse of y of s divided by x of s, it will be treated as 0.01 into, okay, 1 by s square is t into t. Laplace transform is 1 by s square, so 1 by s square inverse Laplace transform is t into e power, okay, since it is minus you will get it as plus 0.01 t. So this is e power positive you are getting. So as t increases, easy t e power positive value is going to be gets increases. So as time increases, the value gets increases and it is exponential. At finally, whenever t is equal to infinite, e power infinite is infinite value. So this is going to be a right answer, which we can prove from the time domain expression as well as from the frequency domain expression, that is transfer function. Okay, so the right answer for this question is A. Thank you.